You are live.
Okay. Thank you. Hello everyone. Welcome again for one more live sessions on this topic of IoT and smart appliances and home automation system. Okay. In today's session, we are going to make very interesting device. Using the device, there are two phases of this whole thing. One is how we can design your own solid state relay in just 30 rupees. Okay, so in just 30 rupees you can control any kind of AC appliances, bulb, fan, AC, and many more appliances, or you can even make it smart with the touch control as well. And then we will integrate that solid state relay with the smart AI solutions for home automations, using which you can also measure the real time. You can also monitor the real time voltage, current, and the billing, electricity billing. It can also able to predict the electricity billing of your end of the month using the usage pattern. You can also add the AI ML model on that, that will enables you to predict the billing based on the current usage scenario. So we are going to take care of all this. So let me share my screens first. Let me show you what we are going to do and how our things will look. So let me share my screen. Okay, so I am going to share my screen. So hope my screen is visible to all of you. Okay, so here is the dashboard that you can see here. Here is the dashboard. You will get a dashboard like this that will measure the real time voltage that is coming in your room, how much power it is consuming, how much current it is consuming, and it will tell you the estimated volt based on the energy usage, and also tell you the energy uses current or energy used by you in real time in total number of unit, how much units you have consumed, the unit 10 unit, 5 unit, 100 unit, 20 unit. So you can manage your electricity uses as per your need, as per your electricity metering that you have set as per your pocket, as for your affordability. Like if you have a limit of the 100 units, then you can monitor real time how many units I have already used and how many units I have left, so that I can save my money on the metering. Okay, it will also tell you using the AI model and your usage pattern that how much the electricity bill by the end of the month in the dollar, or you can set in the rupees and the rate you can also set that in the code. Okay, so this kind of UI you will see. Let me show you the one of the demo video of that. This kind of UI will see. Okay, so that will give you the real-time voltage, current, power, energy uses, and the estimated electricity bill. And you can also turn on and off that circuit, that solid state relay that we are going to make. And this solid state relay that we are going to make, you can control AC bulb and AC appliances, refrigerator, fridge, even the air conditioner as well. With few modifications in the circuit, you can also able to control the air conditioner and fan and all those things as well. Okay, so we are going to make these things. Okay, so first phase of our development is the solid state relay. So very first thing is how we can make a solid state relay. There are, like, for controlling any kind of AC appliances with the DC signal, we need the solid state relay or any kind of relay that will or electromagnetic relay. But electromagnetic relay are a little bit of noisy and not fast, so we are use the solid state relay. So how you can design your own solid state relay in just 30 rupees? Today we are going to make that thing. So once we make this solid state relay, this is a solid state relay that we have seen. I will tell you how we make this circuit, and then we will use this circuit, this voltage and current sensor circuit, to measure the current and voltage and power and electricity uses. And based on the uses, we will implement the AI pattern to get the estimated bill of the month. Okay, so first let's talk about the how we can design this solid state relay. So this is very simple solid state relay I have designed. So as you can see, the AC bulb is connected, and this is the IC, this is triac IC, using which we will make the solid state relay. So let me give you the very simple basic connection of this. Okay, let me remove this part. Very simple basic connection. Okay, so this is the solid state relay we have created. Okay, now if I want to turn on this bulb, I can simply use my DC current. DC current here, like you can see here, I am using the ground pin. This is the ground pin, and this is the ground pin connect here, pin number 2. So ground pin is connected to ground pin, and then whenever I connect this, the light will be turned on. See, light turn on using the DC signal. This is the DC signal, and I can connect it. See, I can control the light using this solid state relay. So what I have used, I have used one triac here, as you can see. The AC power line is coming from here. Here you can see AC power line coming from here. This is the AC power line. Let me show you the another zoom out video. Yeah, so the AC power line is coming. Let me zoom it out. Where is the camera section? Yeah, this is the camera section. Yeah, let me remove the center stage. Yeah, this is the AC power line. Okay, so this AC power line is coming here. Okay, from my back side, you can see the power line cable is from going from the board. Okay, so this AC power line is coming, and that AC power line, one neutral wire is connected directly to the bulb. Okay, the neutral wire directly connects with the bulb, and one wire that is connect to the one of the gate, that is the hot wire, that is what we call live wire, connect with the gate T1 and T2. Okay, in between the T1 and T2. Okay, and this T1 T2 switched using the signal coming from the DC part, and this signal coming from the, and here we have need a resistor of 10 kilo ohm here. So it depends on the triac that you are using. So I just need one triac that is cost you around 6 to 5 rupees only. So using one 6 to 5 rupee triac, and another I need an optocoupler. This optocoupler, with what will take, it will couple the AC and DC all together. Two different circuit. It will isolate electrically but coupled optically. Okay, so it is optically coupling the two circuits, the AC circuit and this DC circuit, using this optocoupler. And by giving this simple signal to this optocoupler, DC signal to this optocoupler, I can switch this triac, and this triac can switch this bulb. Okay, so how many components are used in this basic solid state relay that we have just created? Just one triac that cost you 6 rupees or maximum 10 rupees, and then the IC that cost you another 5 to 10 rupees. So in only around 15 to 20 rupees, I have earlier told you that we will going to make a solid state relay in 30 rupees, but that is the maximum price that you can make. Here in the practical, if you go for the original pricing, in just 15 to 20 rupees, I can control this AC bulb using the DC signal, using this solid state relay that we have just created. So the triac that we are using here, there are lots of triac out there. So triac we are going to use here is BT136 triac, that is from the Motorola, or there are many other vendors are also there. So but originally, sorry, not from Motorola, sorry, this one BT136 triac. Okay, that we are going to use. So using with this, we can control the this bulb and basic fans, very low watt. But if you want to go to control the AC, the air conditioner on heavy loads, then you can change the track with 20 amps or 30 amps, whatever the appliance is going to consume the power. You can change the track accordingly. Okay, so you can change the track accordingly. Okay, as per unit. So for the BT136 track that I am using, let me show you the pricing. Oh, sorry. I don't know what is the bug in this Chrome browser. Whenever I search, it automatically turn off everything. Now I have to restore the tab, and then I will show you. Okay. BT136 track. BT136 TRIAC track. Yeah. So this is the track. This is BT136. You can see at various stores there are different track on the same name with different prices. So maximum price you will get around 12 rupees or 14 rupees. These are available, 12 to 14 rupees or 11 rupees, around this track is available. Then the second component we need is MOC 3041. IC. Yeah, this one, this Motorola MOC 30. This is the optocoupler IC. You can also use different other optocoupler IC. There are a lots of available. Then again cost you 5 to 10 rupees. Okay, so in 20 to 30 rupees, you will get this AC controlling relay. You have created this in just 20 to 30 rupees. So how we are going to design this circuit? Let's see the circuit of this. So uh, first let's see the BT136 track. BT136 track. So it gives you three pins. These are the pin outs. There is a T1, T2, and then there is a gate. Okay. So we control the AC appliances using these two T1 and T2, and by giving the signal to the gate, you will control this AC appliances. Okay. So as per the data sheet. So this let me show you the basic circuit of this data sheet. Basic circuit of here. This track. Let it open. Yeah. So this is the basic circuit. So this is BT136 track. You can see here. BT136 track. And I am using 10 kilo ohm resistor or 1 kilo ohm resistor, whatever that is as per the data sheet, you need to add there. And using the gate, I am giving the signal from the MOC 3041 gate. I am giving the signal to trigger this AC load. This is load. This is load part. So if you are using the inductive load like the motor or fan, then you need to add 100 ohm resistor or 100 nanofarad capacitor for inductive load to make the circuit safe. Otherwise, it's okay if you don't use the this circuit. You can directly use the bulb in such a case. Like I am using directly the bulb, so that is not inductive load, so I can directly use without these things. Okay, and I'm giving this signal from this battery. Okay, so if I want to make this track touch control, I want to control it with any kind of IoT system like this Indus board coin. So I can simply give the signal to the MOC 3041. Okay, using this coin, I can simply connect this Indus board coin to this input of this optocoupler, and I can trigger it. So like here, whenever I connect this, it can trigger. The light will on. Okay, this one is the see, light on, light off. So if I want to make a touch based switch, touch based solid state relay, so I can use this kind of touch sensor. So it again, it costs you around 5 to 10 rupees only. This solid this one. So this is the VCC pin and this is the ground pin. This is the VCC pin and this is the ground pin. So I'm connecting the VCC pin to the VCC and the ground pin to the ground pin. Now whenever I touch, it can detect the touch, and it is turning on the light. See, it is turning on the light whenever I touch it. Okay, now I connect this output. Now I connect this touch output to the optocoupler here. Now whenever I touch, this bulb will on. This is the AC bulb. I am controlling with the DC signal. See, 1 minute. This is the optocoupler output. Yeah, we need to make a ground common between the optocoupler and that. The ground is not here, so let's make a ground common with this one here, ground. So whenever I touch this, it will turn on. See, I touch it. So I'm controlling the whole AC power using this single IC, BT136 track, this single IC. In the similar way, you can also use, you can if you can also remove this circuit. You can also shrink this whole circuit using one single IC. Using one single IC, you don't even need this optocoupler and this track. You just need an opto track IC, this IC. You just need this IC. You just need this IC, opto track IC. This is the VOC 2220. Okay. Using this opto track IC, I can control the AC signal. I can control, I can control the AC light. Okay, I can control this bulb using this up to the 1 ampere of load. Okay, so I can even shrink this circuit to this kind of circuit. Okay, BOC 220223A. This one. This is opto track. So I just need to give the signal and it can control the light bulb value. Okay. So like here, BOC 223A. This is from the Bizarre electron. So the one is we are using the earlier we are using the MOC 3041 MOC 3041, that is from the originally this is from the Motorola, and there are various other vendors are also producing the same optocoupler IC, and then we are using the track one BT1306, and similar track IC for the higher load you can also find in the market around 10 to 20 or 30 to 40 rupees. It will vary. Okay, with different vendors. There are lots of vendors for the tri optocoupler out there. So you can use that for the solid state relay. If I want to change this whole circuit, I can simply use this as well. BOD223T. Okay, for opto tri. Okay, this one. I can control the AC signal using this. Then our circuit goes like this. We can simply simplify the circuit using that. Sorry, 1 second. This one, VO data sheet. Let me show you the data sheet. Yeah, this one. This one. Using this IC, I can control the AC signal here. Okay, so I can give the signal from this microcontroller, this Indus board coil, and I can control it. So you can use any kind of IC. This VO for up to 1 ampere, up to 1 ampere of current, I can up to 1 ampere of current and 220 volt of AC load or 600 volt of state voltage. It can able to control this AC bulb. Okay, using this. Okay, using this IC. I can also use the combination of this BT13006 IC and MOC 3041 combination of IC. I can make the solid state. So there are lots of way to make the solid state relay in just 30 rupees, 20 rupees. You can add the touch switch using this, like here. Whenever I touch it, I can light up the bulb. Okay. So it's very simple circuit. I can control the AC appliances using this DC signal. I can simply touch it. Okay, you can make a simple push button switch. So you can remove this mechanical switch out there on the switchboard, and you can simply put a small tactile switch on the board, and behind that you just need to make a PCB of this strike BT1306 or this kind of IC, BO2230 IC, optotrack IC, and you can control this AC bulb. Okay, using this tactile switch as well. Okay, so see, whenever I touch, it is turning on and off. Okay, so this is a basic optocoupler based or optotrack based system that you can make and control the AC appliances using the DC signal, and you can make a solid state relay in just 20 to 30 rupees only. So if you look at the pricing of the touch switch out there in the market, let me show you the pricing of touch switchboard. So for the 3 switch, it will cost you around 1449. For this much of switch, it will around 17,000 rupees. And you just need 30 rupee, 30 rupee, 30 rupee cascading circuit, and you can make 10, 20, 50, 30, 100 appliances controller touch switchboard in just think just in just 30 rupees you can make a one touch based IoT controller board, while here for the 17 or 20 appliances it will cost you 17,000. So around 100 or 200 rupees you can make such touch switchboard like this 17,000 appliances you can make it in the few. Here I can simply bring the it can work behind the plastics as well. So this is a plastic. Okay, this is the plastic. This is the plastic. Okay, I'm keeping a plastic here, and just bring my finger here, and it can detect my touch. See, so you can keep it behind the board as well, behind the glass like this, like this. This 17,000, 9,000, 20,000, 4,000, 6,000 devices. This touch switch board you can make in just simple. circuit. Let me zoom into the circuit for more details. Okay. So here, this is the, so as you can see, this is the triac. This triac, one neutral wire directly going to the AC bulb, one neutral wire directly going to the AC bulb, and one hot wire, that is the live wire, connected to the T1 and T2, in between the T1 and T2, and between the T2 and there is register, and this gate, we are providing the signal to this gate, and this gate is turning on this on and off. Now whenever I want to add a touch switch at this, I can simply use 10 rupees this touch module, and control it. If I want to make an IoT controller, then I can simply use Indus port coin and connect this gate to the Indus port coin. I can control using the Indus port coin. Then let me show you. So this is the Indus port coin here, and then we will go for this AC power monitoring. This AC power monitoring after that. Okay, so our first part is already you have got this AC power monitoring, how you can measure the voltage and current and power electricity bill. I'm going to that part now. Our solid state relay part is ready. Now let's control this solid state relay using this one, this Indus port coin. Okay. So I just need to connect this Indus port coin. Okay. And I can upload the code here. I can upload the code here. So this is the code for whole this dashboard and IoT controller. Okay. So it will give you the bill, estimated bill using the AI model, using the pattern. It will give you the what is the estimated bill by the end of the month you will get if you use the similar way of electricity. It will give the real time voltage, current, and power and all those circuits. This is not changing right now because nothing is connected here. Okay, and this board is not connected there right now. Okay. So let me upload this code. Let me upload this code. Okay. So this is very simple circuit. You can make a whole AC controller. I can control this whole AC using this single IC, or even this IC, this simple IC. And there are lots of IC out there. Many companies are making this. For BT136, there are lots of IC are there. Similar IC. For more triac IC, there are lots of more triac IC that will give you the higher load. You can control the higher load like AC fans and many more. Or for the simple valve, you can also use this kind of triac, opto triac with the single IC. With this single IC, I can control. So let me show you the video of that. Okay. So this is the one of the video I have taken because I have already using the triac. I have already using the connection with the triac here. Here you can see I have already using connected this bulb with the triac. So right now I'm not using this IC, how to control. Let me show you the video how I am controlling this IC. So this is the IC. The AC line is going here, and this is the signal coming from the DC. So this whenever I connect this IC to the signal, the bulb will automatically light up. See. So when I reinsert this IC, it will get the signal and it will turn on. See, the bulb will turn on whenever I connect that. See, the AC bulb switched off with this single IC. I am giving signal. Detecting my presence right now. See. So this is the AC. This is the AC wire connected with this IC. This IC, AC wire, this IC. These two wires, these two pins connect with the AC. This one, this hot wire, the live wire, and this one part of the DC part. Okay, for the optocoupler one that is connected inside the IC, that is integrated inside this IC. So inside this IC, there is a triac and the optocoupler, and whole thing is combined in this one single IC. So this is called opto-triac. That's why we call it opto-triac. Okay. So now I have uploaded this code. Let me check the code is uploaded or not. No, it's still compiling. Oh my God, it's taking a lot of time in compiling. Yeah, so here later I will tell you how we can connect the voltage and current sensor for the billing and monitoring thing. Like currently we are using the pin number 4 to control the bulb using the solid state relay we have just created. Okay, and later we will add the power monitoring circuit to the solid state relay so that I can also control the AC appliances, and I can also check the billing, how much power it is consuming in the real time and how much estimated bill of the month based on my current usage scenario. So when a code is uploading, let me connect something here. So there is a ground wire, this ground wire. Code is uploading, let it get uploaded. Till then, let's do the connection. This ground wire goes to the ground. Yeah, connected the ground to the ground up. Let me remove all this circuit here now, right now. Remove this, remove this. Throw it out. This ground wire connect with the ground. I need one ground pin here. This ground pin. And pin number 4 connect with this register. Pin number 4 connect with this register. So whenever this pin number 4 will get the power, this light will turn on. Okay. So suppose that I am giving the power to pin number 4, then it will turn on and turn off. Okay. Let me check the circuit is uploaded. Yeah, code is uploaded. Let me check with the phone connection. Okay. So later I will add the voltage and current sensor to this as well. Okay. Let me open the browser on my phone. This is the phone I am opening. And let me search 192.168.4.4. Here is the UI you can see. Here in the camera, you can see the UI. So currently the reading for the voltage and current we are seeing is wrong because I haven't connected the sensor yet. And all those things, only thing is currently we have connected the bulb, so I can control the bulb using this. Okay, see, using this, I can control the bulb. We have first designed the solid state relay in just 30 rupees. Not even 30. ICs cost 9, and the MOC another IC cost around 5 to 10 rupees. So around 20 to 25 rupees we have made the complete solid state relay. Now we are controlling the solid state relay with the Indus board coin. This is the Indus board coin here I have connected. This is the Indus board coin. So it's a 30 plus GPIO pins, and there is a temperature sensor, accelerometer, voltage, and there is a ADC sensors are there. So I can connect all this ADC and connect to the I can control at least 10 to 20 bulbs and appliances using this board and monitor individual power of those using this whole system. So how much current my fridge is consuming, how much power my bulb is consuming, how much power my TV is consuming, how much power is my AC is consuming, everything I can see in the real time, and how much estimated bill I will get at the end of the month, I can get it all in the real time. See, this whole circuit is connected. Right now, currently I have not used the power monitoring circuit. I'm just controlling the bulb using the solid state relay that we have just created earlier. See, off, on, off, on. And here in this tab, it will show you the billing and all those things here in the camera. Let me show you in the camera here. See. So now go for the power monitoring circuit. Okay. So for the power monitor, let me first turn it off. So I am turning it off. This is the AC. This is the AC signal. It is controlling the AC signal. This single IC, this small IC is controlling the AC signal. I will just click it and the bulb will turn off. This is the whole AC signal. Okay. So here how it is connected, the Indus board coin, I have use the pin number port. If I have more bulb, more fridge, more AC, then I can use the pin of 5, 6, 7, 10, 13, 20, 35, 36. There are 30 plus IO, plenty of things you can control. Okay, plenty of things. And there are lots of sensors already there in the board. Okay. You can, so I am controlling the bulb using the pin number 4. So I have connected this pin number 4 and make a ground common with this MOC IC, this optocoupler IC, and this thing. Now it will give the signal, and this optocoupler will give the signal to the optotrack gate, and this bulb will turn on using this single IC. See, this is the AC. This IC is taking the AC signal. So sorry, AC power line, and controlling the AC power line. This is a small tiny IC. It's just this much. It's just this much. Okay. So or if I remove this whole circuit with this IC, so with this small circuit, this one small IC I can control, and this small IC combined with this small tiny board. So in this small size, in just 3 centimeter of size, I can control any kind of AC appliances. This 3 centimeter size of device. And if I want to monitor the power, I just need this thing, this one voltage sensor and one current sensor. Okay, and using this voltage sensor and current sensor, I can even get the power. And if I can even shrink this, there is just IC for voltage and current monitoring, AC voltage and current monitoring that come in this size. So over this 3 centimeter of size, I can monitor power. I can monitor how much units of bills I have. I am getting by the end of the month. I can run the AI things, everything. I can control the whole appliances in my room using different switch. I can add it here. I can monitor the voltage in my room, in my home. I can measure the current that each of my appliances is consuming. I can get the power, how much each appliances is coming. I can monitor the energy. I can estimate the bill. I can estimate the total monthly bill based on my pattern using the AI model. All these things we can do. All these things in just tiny 3 to 4 centimeter of device. So now we are able to control these AC appliances. Now let's add the power thing. See, I turn it on, it's on. I turn it off, it's off. It's very simple. It creates its own Wi-Fi network. We will go for the coding part in the next session. Let me go for the connection part. Okay. Now for the power monitoring, here I am using, there are lots of options for that as well. Like I've told you, there are IC that will give you the AC current and voltage monitoring IC. You can search online. AC, CORRENT, and voltage. You will get a lot of IC out there that can help you in that, this kind of IC, if you want to shrink the circuit. But here I am using the modules. Okay. So I am using this module. This module is ZMTP voltage sensor. This one. Voltage sensor 101B. This one. 101B. It will cost you around 85 rupees. And then we are using ACS current sensor. This is the ACS current sensor. So this is the ACS current sensor. That will again cost you around 70 to something rupees. This is the ACS current sensor. So let me show you the connection, how we are going to do the connection for this. Okay, so let me first remove this part. No, let it be. Okay, let me show you the connection here. Let me move it a little bit this side. Yeah, now this connection. Okay, so I have used this kind of tape to organize these things. You just ignore these tapes. Okay, to make it more organized. Okay, because we are working with the AC, so we need to be careful about that, the short circuits and all those things. We need to take care of this. Okay, so yeah. So this is the ACS current sensor. So power line, the hot wire and the live and the what you call the live wire, someone called the hot wire. So hot wire or live wire, whatever you want. I'm taking using the hot wire terminology here. So the hot wire and the neutral wire both goes here in the voltage sensor. Okay, both goes here in the voltage sensor. Now it will measure the voltage. Okay. For the current sensor, one of the hot wire, this hot wire, okay, one of this hot wire will go to the one of its terminal, ACS terminal, and that same hot wire, one of the hot wire, I will cut in the middle, and the other that hot wire other ending will go here. And this will connect to this power line of the bulb, this power line of this bulb. Okay, this power line of the bulb. Okay, and the neutral wire then connect to the direct neutral power line of this bulb, and this will again connect to the plug. This part will connect to the plug. Okay, right now this is connected on this configuration, so I am not touching it here because it is the AC line. I don't want to do short circuit here right now, because we have need to careful connection with that. But I have told you that this connection will go to the opto triad, like we have done it here, and this one go to the plug. This two wire goes to the plug, and okay, and after that it will start giving, and then you need to upload this code, and then it will give you the total billing and all those things like this. Total voltage, total current, total power it is taking, and based on the usage, it will tell you the total end of the month electricity bill, and it will also tell you the total units. Here it is not showing any unit because we have just started it, so it is not showing any kind of unit here. Okay, so let me go for the code part. Okay, let me go for the code part. Code part I will explain more, and this AC current thing I will cover one more session on this and give you more details with live connections. Right now I am taking only solid state connection right now. Okay, I will take more session on this. Okay, yeah. So here we are using the async web server, that for because this Indus board is hosting the web server, and pin number one for the voltage sensor. So the current the output from the voltage sensor connected to the pin number one, and output from the current sensor connected to the pin number three, and relay I am connected to the pin number four. So if you want to monitor one more appliances, then you can use pin number 5 for the voltage sensor, one more, and then one more current pin to the pin number 6, and then one more relay pin number 7. Then you one more device set is ready. So for every device you can keep adding this number. There are 30 number of GPIO pins. There are enough up there. Okay, and then we have some of these what say data types, the floating, and so that we can store the values. Okay, and then we have the web page UI that we have created. Okay, this is the HTML web page UI. So if you copy this HTML file, this is the HTML file that will create the web page UI and upload it. And this is the JavaScripting here. And this is JavaScripting here. Okay, so this will online. You will get this kind of UI. So if I want to add one more button, then I want to add more appliances, then I can simply add it. I can simply change it and keep adding it. Fan, fan. See, voltage fan, one more card is added here in the UI. If I want to monitor one more AC voltage, I can simply add one more line here. Voltage, air conditioner. And when I run this code, one more card will be added in the UI. See, air conditioner. So in this way, you can create the UI in HTML, JavaScript. And then we have the loop function where it will where it will, this is the code. Yeah, where, where it will take the data from the sensors, calculate the voltage and calculate the current, and then take the energy and use its algorithm to find the estimated bill. Okay, you can also run the AI model on this. You will need to create the data set and then you need to run the AI model. For the AI model, I will take one more special class on this later. If you need, let me know how you can create your own AI model based on the data set. So it is also using the AI model based on some algorithm. So how you can create that AI model, your own a model, a machine learning model, how you can create that? That is a very vast and very separate process. So I will take another if you want. Okay, you can comment me on the. You can ask me. Okay. So this is for today. So you can see how we can create, and after uploading this code, I can able to get this kind of UI. I can control the bulb. I can get the voltage. I can get the current. I can get the power. I can get the total energy used in the units. I can control the bulb. Our thing is ready. See, see, this is the AC circuit. This is the AC hot wire. This is the this is AC hot wire. This IC. And whenever I put it here, it can turn on. It can turn off. It can turn off. It can turn off. It is giving me data in the real time on my phone. I can connect n number of phone, n number of device using the Wi-Fi that is hosted by this. See, it's like magic. So this is AC bulb, this is AC current, and I can controlling using the DC. I using this single IC. So isn't it look like a magic? Okay, thank you everyone. Thank you everyone. Thanks for joining.